Okay, so is everyone able to see the screen?
Yep, it's confirming.
Okay. All right, so yeah, good morning. My name's Jacob, and I kind of took it on myself. I started out with an interest in the potential emerging market for mass timber in the United States, kind of more broadly, and with a recent project by Lake Flato Architects in Boca Powell and San Antonio, mid-rise office building going up out of mass timber. I began to become interested in, what are the potentials for this resource or this building system in the Southeast United States, obviously with southern yellow pine being abundant, different physical qualities than other species of tree, but with a long history of, lightwood framing and other infrastructure uses in the United States. I decided to start to consider the possibilities for essentially mass timber in Texas. So I will start here. I began looking at Austin, just growth plans, looking at population projections provided from the Austin Chamber of Commerce, just using census data from the last decade, and then their projections through 2030, 2040, and 2050 for the city's growth. Kind of goes without saying that Austin has urbanized quite rapidly in the last 20 years. So I started looking at Imagine Austin comprehensive planning for the city, just starting to think about, where are these nodes or centers that could start to produce more urban environments in the coming decades. And again, here is where I began with looking at these projections of population growth, and was able to get in touch with the right people at the Macomb School of Business here at UT to work through CoStar as a real estate development data source, and relate this trend over the last 10 years of population growth in Austin to some of its mid and high rise structures, buildings able to break them down by building superstructure. So I was actually able to get a report. We were able to generate a report of inventory units for multifamily residential and square footage for office buildings being built over the same time period as the growth measured by the census data in Austin. So what this started to set up was building stock per capita projections, not necessarily in a literal 1-to-1 ratio where everyone who moves to the city, moves to a mid or high rise building to live or to work, but to establish a relationship between the growth of the city overall and the growth of its corresponding mid and high rise architecture as well. So I decided from there to look at multifamily residential for building typology and kind of move forward with the research on that basis. From there, obviously the 2021 IBC is something that a lot of people are very interested in right now. Some of their type 4 construction, breaking down heavy timber into A, B, and C, and considering various heights that are new to the United States out of the material. So from there, I started looking at precedents, and for me, the overwhelming driving precedent for considering the potential to achieve competitive floor-to-floor heights and leasable square footage in a mass timber high-rise to something like a reinforced concrete frame. I started looking at the Brock Commons Tall Wood House in the University of British Columbia, and their student housing building, which is, for those who don't know, the tallest mass timber building in North America. So I think also I'll kind of relate this back to, through looking at the real estate metrics with CoStar, it was overwhelming that for multifamily residential high rises in Austin, reinforced concrete frames are what we've built with historically. So that established a sort of a baseline comparison in terms of looking forward to life cycle analysis and a competing market. So looking at the construction, the composition of the systems, I was looking at the two-way flat plate system that Brock Common uses for CLT and the tube-in-tube glue-lam column connections. So here I'll actually drive for a minute and zoom in. I started with establishing what set itself up as a pretty efficient use of, as best I could get efficient use of the CLT bays for kind of a prototype floor plate system out of the two-way flat plate slabs and the glue-lam. So I started with this framing plan to kind of work out a building mass using StructureLam as a resource to maximize the spans for the CLT. And then from here, considering the same or similar as Brock Common's panel system to clad the building overall. And then these are just, a few of those connections and some of the systems that started to set up what the prototype building could look like. So in order to determine that I was comparing this to relatively, at least, an arguably close concrete baseline model, Uli actually was able to put me in touch with an engineer that had worked for Fast and App during Brock Commons, and since works for Intuitive Engineering in New York, a structural engineer that is professional in, has a history in both concrete and mass timber structures. So working with her kind of as a consultant and some professors from the School of Engineering, or a professor from the School of Engineering as well, and another student, master's student consultant, was able to work through an ETAB structural model of, defining what a relatively accurate quantity of concrete would be for a baseline prototype comparison. So this set up 3 design options for a concrete frame prototype, one of which being, or for a frame prototype, one of which being the concrete frame, the next being a concrete timber hybrid frame, like we see with the Brock Commons Tallwood House, and a third option being a steel timber hybrid frame, which was something that came out of a discussion with Tanya Luthi, the engineer from formerly Fast and App and now Intuitive. She had mentioned that had the project timeline been something that could be accommodated a little better, through further testing, a steel timber hybrid frame, the steel being the core, the podium and the core, is something that could have been done at 18 stories. And she felt that, especially in this seismic zone, it was something that was achievable. So I thought that could be a really interesting third comparison. So this setup, basically we see down at the bottom of these models, you can see my mouse, taller floor to floor heights. So this established a sense of a podium for a prototype building, trying to be reasonable and accommodating something that could actually exist within an urban fabric and work to the streetscape, et cetera, to have retail and a lobby and potentially amenities as a gasket deck, before then turning above to tighter floor to floor for the residential units. I should note, for life cycle analysis, there was no foundation assumed for any of this. So everything just started with columns kind of at grade, working from there. And then here I just have some general cross sections of some of what was tested both in ETABs and in the life cycle analysis. So here's just the timber concrete frame version of that. 3 layers of 5/8 gypsum wallboard and concrete topping were also accounted for in the life cycle analysis for both timber frames, and then steel structure with a cementitious fireproofing, corrugated decking for certain floors as well. So this is, these are just these kind of diagrams of what the three LCA models looked like. And from there, kind of set up an analysis of what the global warming potential for each of these systems was. And it was less about the actual numbers and more about establishing relationships. I used KT Innovation's Tally, a software from Kira and Timberlake, and worked with kind of their leading developer for the software at their office, as well as also had someone who I was able to consult with from Lake Plato Architects here in San Antonio, who use KT Innovation Tally as a Revit plugin for the Soto project, that mid-rise office project that I mentioned earlier. So really, for this, it was, like I said, to establish these relationships between the three structures. A lot of things were considered in terms of drag straps and channel as steel to connect the CLT flat plate system back to the lateral core. You know, all of these things getting taken into account when looking at the life cycle analysis and the material comparison. I wanted to be as detailed as I could with the time that I had to really work with a comparison that I felt comfortable was, you know, somewhat of an accurate representation, and biogenic carbon for these studies was included. So this just starts to set up this relationship. We see on the left, global warming potential of the three design options, basically being cut in half. So not just looking at the carbon sequestered in the frame, but using that as a net to gross deduction, or gross to net reduction from the overall impact of the two timber frames to the net impact, with taking that sequestration number into account to look at what the final impacts were for each structure. So we can see essentially the concrete timber hybrid was about 75% impact, a little less than the pure concrete frame, and the steel timber hybrid was about 50% the impact. So, you know, these started to set up a bunch of other comparisons that I thought were pertinent to the study. Looking at all of these options, I mean, we see the product itself, you know, being an overwhelming number in the data, also end of life, you know, really driving some of these relationships. This is just a look at some of the material. So, I mean, one of the things I actually learned from this that I thought was pretty interesting was just including the finish, the Type X gypsum for the two timber models was actually a really significant, or, you know, what I would say is a pretty significant amount of impact in the overall assessment, though still obviously much better than the reinforced frame impact. So from here, I mean, I started thinking about, you know, if you were to use this material, how could you source, going back to this argument for the Southeastern US, how could you source this locally, or at least regionally, excuse me, versus considering the Pacific Northwest, or, you know, not as much of a relationship to North America with Nordic Europe, but looking at other countries that are starting to bring CLT discussion into architecture and construction methods, you know, sourcing from somewhere that includes container ship, et cetera, I thought could be an interesting layer to just comparing sourcing options for the timber itself. So down at the bottom of this screen right now, I've got the Southeastern United States versus the Northwest versus Nordic Europe. And I worked through some logistics in tracking CLT or, you know, all timber products from Austria moving through Antwerp, Belgium as a port, and then container shipping to Texas City, just outside of Houston, and then bringing that to the site in Austin. So that set up a mileage that's a little bit more involved than just these graphs, but these illustrate the overall miles traveled for the material and then for the product for both trucking and container ship. So I started thinking about how this could play into the East Texas piney woods and the resource that we have right here in the state. Obviously, you know, at mass scale, this has mass implications as an introduction to Austin or to Texas urbanism in general. So I thought it could be interesting to start to look at the supply for the state and start to relate that back to the buildings and the potential stock, considering sustainable growth harvest, net to gross harvest that we have right now growth to harvest ratios that we have reported currently for the state, and considering what the potentials are right here in the state, looking at saw timber of large enough size to accommodate these systems. And just, you know, this also goes in to this notion of Structurlam bringing a new facility to Conway, Arkansas in the coming years, and, you know, just starting to think about what sourcing from such a close location could imply. So looking at the timber frame model, this is including biogenic carbon, just looking at some relationships between end of life cycle or end of life versus the transportation versus the module. And for the three design options now being sourcing southern yellow pine versus Douglas fir versus Norway spruce or mountain spruce, just to start to learn what the impacts of the transportation are for the overall sourcing of the material. And then excluding biogenic carbon, you can just start to see what impact the product has in relation to the end of life, in relation to the transportation overall. So, I mean, just starting to look and learn from some of these relationships. And, you know, now they're starting to bring into the conversation the use of, or the inclusion or exclusion of biogenic carbon and how that changes some of the data. So then this gets established to the concrete baseline for the amount of concrete that it would take to produce that same volume of building and same square footage. So everything kind of broke down to some later findings in including or excluding the biogenic carbon and relating that to the impact of the reinforced concrete frame. You see here with southern yellow pine, I was actually netting negative on the sum of global warming potential total versus barely netting positive for some of the other sourcing options, which was dramatically different than the reinforced concrete frame. But then excluding the biogenic carbon, I started to find numbers that were closer to half or even greater the impact of the reinforced concrete frame. So just a lot of discrepancies with that. So this turns into architecture at some point. So I started working through some of the comments that were made by Tanya Luthi from Intuitive, and just telling me about some of the difficulties that they had working with this two-way flat plate system. You know, balconies are difficult. I could see why. Architectural form is difficult. I mean, you can kind of see that with the Brock Commons building. It's very extruded. So I wanted to look at this in a context of downtown Austin and start to derive some architectural form that, you know, could hopefully produce some interesting architecture out of these systems, just to give, you know, vibrant building design. So this is an example layout of 7 units per floor plate of studio, 1 bedroom and 2 bedroom capacity, and just breaking down some of the net to gross square footage. The efficiency of the floor plate is about 9/10, factoring in the core. And then this starts to look at some overall massing for the building and its relation to the creek, and thinking about one specific design and how you could use these panel systems and the potential to inset some balconies and try to accommodate the tight columns and establish a form that could hopefully be elegant and viable as an architectural solution to a downtown city skyline. So I, for the sake of accentuating the podium, kind of sliced the massing down to the Shoal Creek Greenbelt that's found nearby, and then similarly kind of tipped the mass up top to allow for this really nice overlook to the Capitol building and Judges Hill to the north, which is a very green, low part of the city. And then this rises the mass up on the south side of the building to cover, chillers and rooftop equipment. So it's just, it essentially you can work to create architecture out of a very rigid and simple system to start to derive some form that could hopefully be more interesting and compelling, or interesting and compelling in general for these projects. So this is just kind of a view looking back from that Shoal Creek Greenbelt. So from here, some of the conclusions, at least so far with the research, fall, similarly to a lot of the discussion that Alan and Andrew have in this timber topic for the industry right now. So looking at different modules, different design potentials for the building and how they affect metrics, I thought could be kind of a nice conclusion, at least so far too. And I say so far because I'm still very interested in all of this, obviously. Just to try to wrap up some of the study and look at relating now the life cycle analysis metrics that I got through Tally back to the per capita relationships of the real estate data and the Austin population. So essentially some of the findings were that, given the steel timber hybrid frame performed about twice as efficiently in terms of global warming potential as the reinforced concrete frame, the concrete timber falling somewhere between the two as an intermediate, you start to see not the relationship of the sequestered carbon, but that being factored into a relationship of per capita projections just in terms of multifamily square footage per person as the city grows, and how that works into tons of CO2 folding into the coming decades over time, and what the potential reduction implications could be, at least at full acceptance of the material. So 100% usage is as far as I was able to get with some of these comparisons. So you end up with as much as 2.5 million tons of CO2 over the next few decades with looking at a steel timber hybrid frame versus some of these reinforced concrete frames. And then this just had some fun with, thinking about what the actual implications of this are in terms of, how many vehicles is that taken off the road annually, and some of these other relationships. And then this diagram at the top just goes back to illustrate, and thinking about the workflow of the project. It's as the population increases, creating relationships to how building stock increases in terms of square footage, creating relationships to the materials that we use to derive the square footages or derive those buildings. And then relating those buildings back to the population kind of brings like a full circle look at what these implications are, and what you get with some different options and some different residential units packed into different massing, as much as 1,000 to 1,500 tons of CO2 reduced per building. And that is it. So I just want to thank everyone for listening and kind of open it up from here.
Thank you, Jacob. Wonderful work. I've commented many times throughout the semester on your work, and I followed your progress closely, and it's wonderful. I love the way that you've gone into such depth with the per capita carbon footprint, because normally it is by unit. So that gives a whole other understanding to this that I think is so important for understanding the potential of the material. But I do want to open it up to your other reviewers, since you haven't had as much time with them. So
yeah, thank you, Julia. Is there a way to let other people drive on the screen share or anything? Like if anyone wants to point, or I can tab through as necessary, just let me know.
Yeah, I mean, I don't know if they are. I think they're able to move it within their own mural, I think, but yeah.
Yeah, it doesn't seem like we can annotate. That's been something we've been able to do in the past, but I'm not seeing that
well,
often.
that was, I did not set up this meeting, and probably that function was
Well,
disabled.
I can wave my hands, a lot. Okay. Well, I'll jump in. There's, first of all, Jacob, this is incredible work. It's deep, it's broad, it's nearly comprehensive. I have a couple of questions about it, choices you made methodologically. But I just want to open by saying that this is the kind of work that architects, engineers, builders, the building sector in general should be doing to evaluate their consumption habits, and also to feed back information as as Juliana said, back to behavior, right? Like how much consumption we as consumers, dwellers, are responsible for, and also the associated, impacts of the building life cycle. And I think there's, so any comment I have from here on in that's a question or maybe a criticism is couched from a position of me being completely impressed by the work. So I just want to make that clear from the outset. The first question I have is, I understand the conventions and the economic transitions within the building sector and the political economy of building in general that would make you try to rein back a really aggressive approach to using timber. But I'm just wondering, why is there not a fully biogenic building as a sort of a bracket to this research?
As a full timber frame,
timber core, lateral resistance systems, partition systems, insulations, weatherproofing, right? I mean, not to say that these technologies are ready at hand and easy to get in Austin or New Haven or wherever you might be working, but they are emerging. So I'm just wondering about the kind of potential in a carbon stressed economy, right? Or with any of the other life cycle attributes of building where resources are starting to be scarce because of policy or because of just pure availability or economic feasibility, right? We're in an economy of scarcity. What happens if we don't look at that next step where you just go, okay, we have, gazillions of saw logs and southern yellow pine in the southeastern wood basket, and we can turn all of these products and the byproducts of harvest that might not be merchantable right now into building. That's a question, I guess, like why you chose not to pursue that. Was it available material and tally, or what was your?
Yeah, I mean, I think it was just, well, I will speak to the overall driver. Maybe the thesis was driven by too many truths or certainties at times with, some of these comparisons, and just not having a precedent of a building at that scale to work with, understanding just the quantity of timber and that associated with getting a 180 foot timber frame out of like a flat plate system to keep the comparison similar. Mm-hmm. I didn't consider it, just for not having anything to go off of yet.
And again, it's not so much a criticism as just wondering about how we bracket the kind of excellent research you're doing, and how, when we bracket that research, what we do to the prospect of transitions, right? And so I guess that's more like the next step in what I'm no doubt will be a really great career in research and design. Could you be the guy, or maybe working with Diego, could you guys be the people who are starting to really criticize all, I thought one of the most poignant things, not one of the most, but a particularly poignant thing that you pointed out yourself was chipboard, which has this huge carbon footprint, huge set of impacts. No one knows where the gypsum mines are, where this stuff is mined, as we've all said. We're completely disembodied. And even the code still at 18 stories requires that we coat our building with that stuff, right? And you showed that impact, and I think that's really valuable. So what would be the substitution benefit in shifting to some kind of bio-based panel, which of course there are many. They don't provide, admittedly yet, they don't provide the fire protection. I admit that. So I understand the sort of feasibility. But I guess for me, the thesis is something that not only does really hard, close research to existing conditions, but it also proffers technical as well as design futures, right? And I think what's implicit in the amazing work that you've done, and I throw these adjectives in not lightly, because I'm really, really super impressed by the work, and I look forward to poring over it in much more detail. I think that's a way I would recommend that, given the incredibly narrow window for climate action that we have, and given the enormous share of responsibilities that we hold within the building sector for anthropogenic greenhouse gas emission, that's a thing where I think we got to move the ball forward really fast. So that's a kind of generalized comment, and I should shut up. But because I think that one more comparison would show us something radically different, and that might incentivize policy, development strategy, any number of wedges in the climate action field that could really start to move the dial.
Yeah, those are great comments. I really appreciate that. And it's just not to take time away from anyone else speaking, but just to speak quickly on that. I think it's less of at least my feeling of that is it's very well received, in that it's not a hindsight's 2020, but where can I go from here kind of thing with some of the findings already. Thank you.
Yeah.
Yeah, I've got a few comments as well. I would second everything Alan said about how fantastic your work is here, and really appreciate the depth of analysis, and also the design sensibility that's been applied to it, and looking realistically at various different construction implications and detailing and so on. So it's all very impressive. I've got one just sort of minor technical question, and then a broader one. My minor question was, you mentioned briefly at one point that that the lowest carbon system was actually negative in its global warming potential, I believe, under the Southern Yellow Pine scenario. And can you just explain why that is? What was leading to it being negative? I think it's over there on the middle right of the view we're seeing right now, where there's some red in a rectangle.
Yeah. 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 Okay. Here it is. So essentially, what is driving that number with biogenic carbon included to be negative is that the amount of carbon sequestered in the mass of the timber, and it being sourced so locally that transportation isn't kind of overwhelmingly consuming the offset of the resource. It's holding more CO2 than it's the system, at least the tally is saying that option is sequestering more tons of CO2 than it is emitting, and then it is through making the material. So
got it. Okay, that makes sense.
And that's just for the timber. Yeah.
Yeah, that makes sense. One sort of general comment is, I think you didn't consider operational energy. Am I correct about that?
No, I did not. That's excluded from the study.
Yeah.
Because doing these superstructure, the frames, I didn't have a full building that I was looking at.
Sure.
Yeah.
And I mean, the breadth of what you did look at is quite impressive. So I don't consider that a fault of your study, but if you expanded the system boundary to include operational energy, you'd probably see an additional improvement in terms of the carbon footprint. Probably small given the size of the buildings, but you know, a comparative envelope built out of CLT versus like a concrete panel system or a metal stud system that might be used for the walls would probably perform a bit better. Although that's probably not the majority of the energy load on the buildings. So that's another little tick in favor of this. I guess my broad question is.
I'm sorry, I have a question. Sorry, this is Ray Zaferon from Civil Engineering. So are you stating that the mass timber building would have a better performance in terms of energy efficiency during this use stage? Could you elaborate a little bit about that? Because at least from the civil engineering structure, when we're thinking about designing buildings such as masonry and concrete, the fact that these are heavy mass buildings, you tend to have less HVAC requirements for it, because you're able to use the thermal mass of the building to offset some of the energy. So could you just talk a little bit about your justification for that?
Yeah, sure. And you know, this is only based on speculation, but my hunch is that you would find that you've still got an enormous amount of mass in a mass timber building between the wood itself, which has a pretty high heat storage capacity, and then all the stuff that's inside it, including a ton of drywall and whatnot. So I think you would still have an equivalent kind of performance out of the mass aspect of it, but you have a lower conductivity of the wood material itself, especially because the most common approach to cladding a building like this would be with a metal stud system. You put insulation between the studs, but you still have only about half of the net R value of the insulation and its performance. And then if you assume you're trying to keep the other variables equal and put the same amount of continuous insulation outside of that, then you probably have a little bit better performance out of the envelope. That said, the skin loads are probably a fairly minor fraction of the overall energy consumption of a building like this. So I don't think it would be an enormous boost, but my guess is it would be.
I think that would be interesting to compare. In calculations, you can simply try to figure that out. But I also think there may be thermal bridges that comes about from that cladding system. So I think more needs to be explored there.
Sure. Yeah. No, absolutely.
So Jacob was very modest when he said he did not consider operational energy. While he didn't calculate it, he did consider it qualitatively in the design of his window wall ratio. For example, you can see he has very small windows in some of his units, and that was deliberate to reduce the solar heat gain because we are a cooling load dominated climate with hot summers and need for air conditioning most of the year. And he also gave very generous balcony spaces to give a kind of buffer zone for each unit. So while he didn't calculate those geometric changes, I do think they help pull this material to its fullest potential.
Yeah, thank you, Juliana. So I appreciate that point, because what I'd meant is that it was excluded from the qualitative studies that we're talking about, and it was assumed that the superstructure of the building would be clad or finished in a similar system, regardless of what the frame itself was. So kind of excluding all of that from the life cycle analysis itself. But those things are taken into account when you start to look at the architecture with the deep inset balconies, window to wall ratios on different faces, kind of responding to the climate in that sense.
Yeah, and I just, since Dason, you raised the sort of life cycle issue of it, we should also be looking at the end of life scenarios as well. End of life scenarios for the steel and the concrete system are not particularly good in terms of overall impact, whereas wood is generally much more reusable as a system with much fewer post-processing, post end-of-life processing requirements for reuse. Whereas obviously recycling steel has huge impacts, and we're still trying to figure out what to do with concrete rubble around reinforced steel reinforcing. So I think that I think you're going to see, if in our sort of with our systems thinking hat on, the further we look at the true flows of material, carbon, energy through the building life cycle, and include repeated life cycles as part of a kind of circular economic position, I think that you're going to find at timber that operational side is obviously critical, and it's really good that we spent so much time trying to refine that, but that we really have to start looking at that much broader system to get the real impacts down.
Yeah, I think that's a great point. And so to kind of extend that a little bit, my broader question, and I don't have an axe to grind here, I don't have a preconception about what the right answer is, but a question that I've been sort of mulling on for a little while without having really studied it is, there've been some pretty convincing arguments made that, you know, in spite of all the benefits that you've demonstrated here and that we've discussed with mass timber, the trees are actually more valuable in the ground, and we would be better off leaving our forests with more mature trees intact rather than cutting them to build out of mass timber. And I'm wondering if you have a rejoinder or a perspective on that argument.
I'll open this one up to the room. I do not.
I'm going to let Andy take it.
Yeah. This is a topic that's well. First of all, just to echo what's been said, I mean, Alan and I have been doing this work for a long time, and it's really rare to see professionals, much less students, who are so conscientious, deliberate, and thoughtful in preparing such a wide-ranging study. So really, a huge kudos to you. And not only just for preparing the study, but for building a network of collaborators who are able to really reinforce the utility of this to expand beyond, you know, fulfilling a master's thesis. You know, I think what you produced here has some durability that really can carry you really quite far in this field. So to briefly touch on the topic of the kind of best and highest use for forest, I mean, if we're talking about the U.S., what we have is a really systemic issue of undermanaged forests, and that's really true in the Northeast. It's true to an extent in the Southeast, and what's the Southeast critical problem is that 20, 30 years ago, there was a huge kind of stockpiling of planting of softwood lumber in anticipation of this kind of never ceasing building boom, which 2008 really threw a wrench in. And so what we actually have in the Southeast is a huge market surplus for softwood lumber, Southern yellow pine in particular. And there are a number of people working on this, the people who are much more qualified than myself or Alan, who this is a real economic issue for owners of farmland, but timberland, for timber managers, for REITs, for TIMOs, for this kind of whole financial ecosystem that relies on essentially returns for the planting. And what they're looking for is these kind of higher value-added systems. And so what you've described here is not only that regionally sourced fiber is viable structurally, but that it has demonstrable benefits on the environmental side, and at least from your assessment of Southern yellow pine versus Pacific Northwest and European products, it's a huge advantage. And what I really appreciate is that you're taking this to kind of the what does this look like at scale? And so how does this look like at scale for Austin? What could it look like for Texas? And beginning to add quantifiable measures to that. And so when you say something like this saves 2.5 million tons of CO2 over 30 years, it's really interesting because you've now crossed into a threshold of volume that has monetization potential. And so what we were showing it for like a small building or a unit, 1,000 tons here or 1,000 tons there, it's great. It's much better than the alternative. If you were a developer and you could theoretically sell these at $30 to $40 a ton, that's, maybe that could offset your civil engineer's costs. It's not like a huge incentive, but as a municipality or a state or a much larger regional coalition, if you can set up frameworks to monetize at a much broader scale, you're talking about maybe $80 million or $100 million for the city of Austin. That's enough of a lever to start to change some conversations. And so I think that as a framework to inflect policy, it's critical that we as a profession undertake these kind of analyses that not only talk about a building, but talk about systems, morphologies, and applications at a kind of anticipated growth. That I think exactly what you're doing, and you could easily imagine a scenario where you're not only looking at 18-story buildings, but you could expand this to really 6 to 12 stories, which is where the majority of construction is anticipated, and even to a lesser extent low rise. But I think what you have is a framework for an approach that could be built upon and expanded, and really has some interesting potential.
But I would like to speak to Dayson's question about relative strategies, best practices for carbon forests and buildings, because we are talking about a potentially synergistic relationship between the forest biome and the urban environment. And so I would say that what you've raised is a question that's really being debated pretty hotly within the environmental community. I would say it's less debated hotly within the forest science community. That the forest scientists that we're talking to in different regions are seeing the forest as ever weakening carbon sinks, not just because they're retracting because of suburban expansion, because of agricultural land conversions, all of those things, but also they're weakening because of climate change, they're weakening because of mismanagement, and that in fact, as a sort of climax state that supposedly existed, we thought in the forest 50 years ago, there is no such thing. Forests are disturbed. And what regenerative practices do is try to take advantage of those disturbances that are natural and that produced succession growth in forests, that produce other habitat, that promote carbon, photosynthetic carbon uptake. We can actually manage forests in ways that would produce really good material for building. And potentially incentivize forest expansion, afforestation, reforestation, restoration. And so it's really hard right now to measure how much carbon is in the forest and how much carbon is that in that so-called old growth forest. But what we know is there's a lot of mortality, and we can manage forest mortality better to provide stocks for building material while promoting and incentivize forest expansion. So I think it's a super complex question that you raise. And I'd only say that the counterfactual is that we're building for 2.5 billion people in the next 30 years. And if we build them out of the other materials, we're probably going to do as much to cause deforestation as harvesting forests sustainably, probably much more damage, actually. So that's the bigger systems reading that we're having right now.
I just want to chime in here. I'm trying to be quiet because I want to give other people the floor, because I've talked to Jacob, for big portions of the semester. But I actually did speak to someone from Texas CLT yesterday. They're actually they're about to get certification. Ironically, they're in southwest Arkansas. Texas CLT. They're about to get their certification to produce structural CLT panels. And the person that I spoke with, he's also been in forestry for 20, 30 years in Texas. So they're actually getting they're getting most of their raw material from family-owned forests, 100, 200 acre lots. So, there's, a lot of those are obviously mismanaged. He said there's enormous amount of forest loss that of course mortality, as Alan was saying, right? There's a lot of carbon, emitted just through natural, death of trees. So, they're really looking at a very regional model where they're trying to incentivize that and really just create, not just create jobs downstream, but also actually create jobs upstream with the family-owned forest, so that, when he's talking anecdotally about, the grandkids saying, let's cut down the forest so we can drive our four-wheelers around, it's really, it's really easy looking at it as the available resource. Kind of, because that's obviously kind of the region that you're thinking about, we're thinking about for this project. Also interesting, they should probably expand that map because, the piney woods of Texas don't stop at the Texas-Louisiana border. You know, they go into Arkansas, they go into Louisiana, they go into Oklahoma. I wish I could have, you know, made that connection to this person 4 years sooner, but they're actually also they're also setting up a plant in Lufkin in East Texas. So, so along with Structural Lam, there's going to be a second major manufacturer in the region. But kind of in closing, I just want to commend you on your work. I mean, again, just kind of to, you know, agree with everyone else. I mean, the depth that you went into, and also all the little rabbit holes you went down, and, you know, I don't have a whole overview of what you all did, but it's very impressive, and very holistic. And, you know, it's incredible knowledge that you've been able to amass doing this, that, you know, will serve you well going forward, hopefully.
Yes, it really is amazing. Jacob looked at so many different perspectives. He talked with real estate developers, people in the business school, people in urban planning. So it's very, very in-depth research that you've done. And I know it's not possible to show it all in one presentation, but I have to commend your work. It's very thorough. And I hope that when you go into work, you will be very vocal. And I look forward to seeing you as a leader in this field. It's very important work.
Yeah, thank you. I really appreciate everyone's comments. Just to wrap up this presentation and give Diego his time. Yeah, I mean, this is obviously something that doesn't end here. It's a very big interest and a passionate endeavor to move forward with. And I think we've talked about a lot of really important facets to this that I need to learn more about myself, and try to see how, you know, I can help contribute or at least learn from the conversations. So I really appreciate it, and start next month with a firm that'll be in the commercial high-rise studio kind of market of that firm here in Austin. And, you know, everything right now we'll take it as it comes, but in the future, hopefully with this firm and beyond in my career, I hope to help to make an impact with this, with tall buildings or with all buildings. So thank you.
Wild guess, is it Paige or?
Yeah.
Okay. Thank you, Jacob.
Yeah, thank you.
Yeah, thank you to all our reviewers.
Yes, thank you. Very great.
Thank you very much. All right, and with that, I'm going to turn it over to Diego.
Juliana and Uli, that's really impressive work. Thanks for having us.
It's really all that Jacob's doing. We're just kind of pointed him in the right direction and connected him with some people. So
yeah,
great.
And I'm glad that those collaborations were fruitful, Jacob. So someone's washing their hands. Hopefully they're not on the toilet.
Hi, everybody. How's it going? Good morning. still morning. Thank you so much for joining us.
Well, here in this time zone.
Oh, right. In the East Coast, it's already.
Ellen and Andrew are wondering when they're going to get lunch.
I wish we could provide that. You certainly would if, well, I mean, I think
one of the together afterwards too, right?
Current situation is that we get this wonderful panel of reviewers that normally definitely wouldn't be able to fly out to Austin to give us their comments. So just in the spirit of, making the best of the situation, we're happy about that. So I'm just pulling up my boards here and get started in a minute. So many emails to send, see. Okay, here we go. Okay. So. Full screen there. And I just wanted to kind of preface this today by saying, one of the, obviously, my experience at working at Greer Against Architecture was a huge eye-opening experience for me before graduate school, and kind of pushed me into investigating these topics. And I was able to find faculty at UT, such as Uli, that kind of really embraced that and focused that on their research. And so this kind of interest of applying this research project to my home country of Venezuela has a lot to do with a competition proposal I did at Greer Agansky for in Mexico, based in Morelos, the centric region in Mexico. And it just really spurred me on to thinking about, particularly in the Southern Hemisphere, it's something I'll talk about more in length in my presentation, but generally, like the notion of building with wood is widely rejected and not really embraced. And so just the kind of idea of imagining and thinking about utilizing this resource in a more comprehensive way in the region is something that I took away from that. So thanks.
Here you go.
For that.
Here you go. I'm going to just interrupt you real quick. I see that Fernando Lara has joined us, who was your second supervisor here. Thank you, Fernando, for joining us. Fernando is a part of our architecture and architectural history faculty, and he oversees the architecture, well, all the architectural history programs, both the master's degree as well as the PhD program. And Fernando, the other reviewers on the panel today are Andrew Ruff and Ellen Organsky from Gray Organsky Architecture, which is a firm in New Haven, Connecticut, that really focuses on mass timber construction, and they're both also teach at Yale. And then the other known quantities here on the panel are Juliana and Dason and myself. Sorry, Diego.
Thank you, Uli. Pleasure to be here.
Hi, Fernando. Welcome. Thanks for joining us. So to get started, you guys can see my screen, right? Is this confirmed? Good. Okay. So my project is titled Urban Housing in Ciudad Guayana, a case for mass timber architecture. Basically, this independent studio for me was an intersection of several interests, which I would describe as kind of environmental, sustainable, and also like kind of cultural and social. And so I think, throughout the presentation, you'll see that I tried to focus the design around those kind of dimensions and ways of thinking, and certainly trying to bring a certain technical kind of focus on building with wood. So basically, this project is based on the existence of this kind of massive Caribbean pine forest in northeast Venezuela, about 100 kilometer radius from Ciudad Guayana, which is the 4th largest city in Venezuela. It was planted in the early 1950s as a kind of thought as a ecological buffer and as a microclimate regulator for these really arid region. And it actually developed into, it was this kind of experiment of planting like pine in this really dry and very pervious landscape that ultimately ended up working really well. And basically this resource has since gone largely unused. I mean, it's been used mostly for like pulp production and furniture and pallet production, and increasingly has been kind of managed publicly, like through the government, and has fallen into like gross mismanagement. So, at the kind of departure of this project, it looks at this kind of large resource that's kind of sitting there, which is about 1.5 million acres of land, or 600,000 hectares estimated. And starts to imagine with these emerging timber technologies, how that might be put to use in an architectural constructive way, especially considering, Venezuela and Latin America in general, currently faces a really important housing crisis, and it deals with, or has been dealing with for many years, just like issue of like informal housing and not adequate housing, basically. So, here just a few graphics, just kind of contextualizing the project. On the top right, you're seeing Ciudad Guayana and Ciudad Bolivar, which is the capital of the state of Bolivar, which is within 100-kilometer radius. And the plantations basically span two states for a total of 600,000 hectares. Just really quickly here, it's just showing some of the major urban centers around Ciudad Guayana. One of the things I think a lot of projects in Venezuela tend to focus on Caracas as this like big focus, and because it's kind of biggest city. I thought this could be interesting to look at another kind of major city that deals with similar issues, but also is really different in a way. And it made a lot of sense ultimately with the context and my findings there. But fourth largest city in Venezuela, so definitely the largest in this kind of region of these four major cities. Basically, I'll get into a little more of the history of Ciudad Guayana further on. But as a start of the project, especially during last semester, which was more research focused, I took Fernando's history of Latin American architecture class as an opportunity to kind of delve into the cultural past of like wood construction in Venezuela, to kind of see how that would inform what a timber like architecture expression like would look like in Venezuela. So here in the bottom, I'm just kind of showing some of the indigenous construction, which is kind of widespread throughout different tribes and has existed for hundreds of years, and still continues to be built. These really beautiful kind of communal buildings, which integrate the process of building as a kind of very religious, almost ritual kind of action, which I thought was really interesting, and just how those kind of living ways of living relate really strongly to the building typologies. For instance, this kind of hammock house, which is built on this in the Delta Macuro region of Venezuela, these kind of water structures that they hang their hammocks from, and they kind of sleep in there. So it's really interesting because from the kind of spatial point of view, and how they build with all these natural materials and build these communal spaces. And then just looking at just in the history of Venezuela, obviously a big thing is looking at that merging of the colonial culture of like the Spanish culture, which in a larger scope has, I think, a lot to do with like how the material culture of building has been largely replaced with like a kind of northern or colonial way of building, and it has been largely wood construction has been largely abandoned. But understanding how some of that merging of the vernacular construction techniques with the kind of Spanish and European building methods arose and created these really interesting ways of building with cane reed and mud, and kind of using these hybrid systems to build. And then finally, just looking at some of the kind of modern architects, which you could refer to as kind of critical regionalist, and some of the recent ventures of modern architecture in Venezuela, and kind of trying to bring back and some of those tectonic and material expressions in the work. So the work of three architects I looked closely during the research semester. Another part of the research has been kind of just understanding, I think I wanted to kind of mention at the beginning that the notion of building with wood is something that hasn't really caught on, in a lot of areas in Latin America. But just understanding like that there has been definitely an effort in Venezuela to kind of develop an interest in this, and particularly this organization that still exists but is not really as active as it used to be, which is the National Wood Products Laboratory, based in the western kind of Andes region of the country. They just 40 years ago were building these incredible kind of glulam structures for their facilities, and in my research I came across like things like they had consulted with structural engineers from Portland, Oregon to design these glulam beams. And so just kind of recognizing that kind of value that exists there and that interest, and certainly looking at a lot of the kind of research and papers that some of these forestry scientists and architects have written in relation to the material, which although haven't really caught on as a constructive system, because the building market is dominated by traditional kind of carbon intensive building materials, is there. So building on that. Finally, just in terms of the kind of research and precedent work I kind of looked at, UT is kind of famed for having these amazing kind of libraries, and I think that's something that I really took advantage of. I went to the Benson Latin American Library and found this kind of build your own house manuscript from 1964 from Venezuela, which I just thought was amazing. And it's just, these are some of the shots here of it, basically this manual produced by the Workers Bank of Venezuela for kind of working families as a kind of, as a guidebook or construction book on how you could kind of expand your home or remodel it, and going into sort of these didactic, instructive visuals. So I thought that was just really compelling from the standpoint of like, the project for me contemplates just the idea of user empowerment in a sense, and designing a system that can have a certain input from the user as a way to leverage kind of labor as over construction costs and things like that. And this is just another project based in Nicaragua, which looked at disaster resilient housing. And again, just I think the graphic quality of how this idea of community building and people actually following this guidebook and being able to sort of with local materials, build for their needs was really compelling. And then finally, just some, for instance, ideas at a smaller scale. This university in Valparaiso School of Architecture in Chile has been looking at, which is not unheard of, but just the idea of, simple mortise and tenon joinery, like the idea of utilizing pre-manufacturing and milling, with a robotic capacity to then really facilitate the assembly of things on site, or for the use of sort of this kit of parts architecture, which is more high tech and it's sort of pre-manufacturing, and then it becomes a very easy thing to kind of assemble. And lastly, just speak to just this model of, I think we've all heard a lot of, Aravena's half house model, and just this idea of providing an infrastructure that can kind of be infilled or built upon. And in a way, in maybe a certain in a way of contrasting or comparing, this is a shot from the David Tower in Venezuela in Caracas, which was basically this enormous high-rise office tower that was squatted and inhabited. And just from the outset of the project, that recognizing that there's like a certain kind of beauty or value to that, to this resilience of like the user infilling the frame. And just from the kind of economical standpoint also, like if there are a way to basically almost order the chaos or guide it in a way that is productive, and also, obviously not illegal or like invading the property, but just the idea of leveraging this capacity of people to sort of fend for themselves within a framework that can then lead to like the idea of home ownership and just being able to add value to the home. So jumping onto the site, this is a urban map of Ciudad Guayana, not a great one. It's been really hard to find kind of GIS information, so I had to rely on some probably 2000 year 2000 CAD plans. And if I zoom into this plan here a little bit, you can see how outside of the digital line work here, the city has continued sprawling outwards, and I'll get into that a little bit. But basically, Ciudad Guayana stands on this really critical point where the Orinoco River meets the Caroni. It's a really resource-rich region. The city was actually developed as a growth pole. It's really kind of the really young city. It was planned like in the early 1900s or really mid 1900s with the consultation of the MIT Department of Urban Planning, actually. And it was just this idea of basically kind of a Brasilia focused on the mineral extractive processes that the region could hold, mainly in kind of iron ore and aluminum, and just also an enormous hydroelectric potential upriver on the Caroni. So the idea of this city is this just planned growth pole, which is really kind of controversial in a sense, and a reason that I thought would be really interesting to look at this industrial city reimagined in a capacity where you have this confluence. Also, I mean, you have this location of the city in relation to this forest, and just kind of reimagining this industrial potential as kind of the opposite. You know, the potential of wood as a carbon sink, and as precisely kind of the opposite of this in mineral mining. So, you know, in the city plan, you can really see kind of the industrial kind of infrastructure and tissue versus the more kind of organic, natural growth, which is where the town started. So there's, interestingly, just like physically, because of the division of the river, this great dichotomy between an industrial and like more corporate kind of class of usually like a lot of immigrant groups and local workers that migrate across the river. And so in a sense, the project deals with this socioeconomic tension that exists in the city, and maybe tries to respond to it. So going a little bit into the kind of demographics and research I did, and sort of what would guide the design considerations. I'm not going to really go over all of these, but basically looked at a few reports in terms of like describing the socioeconomic metrics, and basically kind of just identified the larger, you know, surprisingly large kind of socioeconomic groups that exist are between lower, middle, and lower class. You know, over like nearly 70% of the population, sorry, over 70%. And just always really noticing this large kind of divide between the two parts of the city. Puerto Ordaz and San Felix are kind of the two, you know, the original town and the industrial town west of the river that could really conform the whole city, but these very large divides in terms of the socioeconomics. And then kind of looking in a sense, I've actually never visited the city. I really didn't have the opportunity to go and travel there for several reasons, but in a sense, you know, the project looks at the fabric of the city in a somewhat removed way, but you know, through these kind of you know, demographic kind of indicators and reports, just able to look at a little bit of the built fabric of the city, and understanding that really a large percentage of the housing is focused on like lower density living. So just, you know, anywhere from like these row house typologies to single family, and these more informal dwellings that are very typical in Venezuelan cities, and a lot less of these kind of more high-rise, mid-rise scale projects. And then just, you know, this is a little more qualitative than quantitative, but understanding that obviously, you know, the building culture is very kind of focused on concrete and steel as primary materials. So understanding that, you know, within the current kind of carbon crisis context, as a way to leverage the potential of wood to combat this very carbon intensive way of building, and also, you know, it serve as a response to the growing needs of the urban population in terms of housing. So basically for the project, you know, just kind of generally like try to focus on these lower class social groups in terms of, you know, economic resources. And, you know, these are just two like profiles based on surveys that I put together just in terms of thinking of the ideal client. You know, not to say that I really looked at like the metrics of material to cost and anything like that, but just as a general target group. You know, you might expect, you know, what parts of the city they might come from, what type of work they're involved in, and maybe their sort of inclination to or ability to even work towards home ownership is probably very low. So likely living in rented apartments or very informal built kind of housing. So, just based on this, a certain deduction, for instance, a lower middle class kind of family might benefit from a more kit of parts construction, something that maybe does involve self-construction, but can be kind of streamlined in a way, like a certain product or system. It might have access to hiring standard labor, so wouldn't necessarily have to build everything themselves. And some use of higher end materials. So these will start to make sense a little later, but there's sort of these kind of assumptions on like what sort of architectural system might respond to the client, let's say. So jumping onto the kind of design, basically this semester I really looked at a very prototypical approach to kind of this like design, like a sort of, it's a very much like a systems-based approach. It's where the specific architectural form is explored, but also looked at in different ways and lenses, in scales. So really just parting from the idea of a very like simple structural grid that is composed of a glulam post and beam system. Kind of difficult to see here at the scale, but basically on a 4 meter grid and 4.8 meter grid in this direction, and then these smaller grids of 3 meters and the cantilever out towards the front. The design evolved from the idea of kind of pushing back the vertical structure and utilizing the potential of a two-way acting or sort of two-way acting decking system, really facilitated by the primary beams running in one direction. But just the idea of kind of recessing the vertical structure and allowing these balconies to create a protection for the building, which kind of factors into this idea of thinking of a frame that is built out but not necessarily immediately inhabited, but kind of slowly developed and built to its end form. So that is a little bit of a loaded statement there, but it will make sense as I get into it. Maybe not describing it in the best way, but these are some of the design logics that come after the plan. So just this idea of these kind of bay, service bays that cluster around the structure and serve these kind of main spaces. The idea of this incremental growth of a unit. So, starting potentially with one space and then growing onto another. And, in the same way, vertically doing kind of the idea of expansion horizontally and vertically within this framework. And this is kind of showing in plan with this there. So this diagram here is really showing basically these ideas and how they translate into potential floor plans. So if I go to my next slide, basically, here you're starting out with your kind of built-in systems, which are provided by, say, a contractor that builds up the frame and the floor system and a temporary enclosure. And the building starts, and certain elements of the building exist, and certain elements start to be kind of temporarily inhabited by occupants and built out. So here is highlighted in blue as a kind of temporary enclosure and temporary interior partitions in red. And then some of the spaces that might not be immediately occupied or finished, but eventually will in green. So this is just kind of one example of what that evolution might look like. So I look, here in this diagram, I'm looking at kind of 3 bay conditions and how those could develop into units. So, this is for instance, a potential studio unit, which again, there's this idea of these service bays that can interlock between units. And so in a way, centralizing those within these bays that can kind of extend vertically in the building and not necessarily have to cross in kind of in the direction against the primary beams to serve the unit. So in a sense, once these cores are built in, they can then be utilized by the way, by the basically the idea, the potential floor plan that would give you a bathroom or kitchen, for instance. And then so from there, branching from the concept of vertical growth, the potential of these units to start to open up and loft to create these more dynamic vertical spaces within the units, and provide, so the idea is the project develops this, the proposal develops this kind of spectrum of adaptability to different conditions and needs, and potentially contemplates just the coexistence or co-inhabiting of just users with different socioeconomic needs, so that they would kind of inhabit or build part of their units, potentially that's sort of one branch or stream in different ways and according to different means, if you will. So just finalizing this slide here, looking at the constructive systems as just again this kind of matrix or a spectrum of possibilities. I think I was just really excited to just embrace the idea of like a more low-tech approach to building with wood. Understanding that in Venezuela, really there's just a very basically unexistent kind of structural wood market. But thinking of this project as a potential catalyst that can start to build with wood and incrementally deal with both the kind of visual acceptance of the material and kind of explore alternative hybrid ways of building that are more low tech or just suited to the local resources. So going back to just the idea of this glulam frame, which is the base system, which could be built out of Caribbean glulam, Caribbean pine glulam, and then transitioning onto looking at the decking and cross bracing material, which potentially could be something from dimensional lumber that could be these kind of box floors that are built out with solid decking, solid wood, and utilizing more conventional cross bracing systems such as steel rod, or going into systems such as NLT with OSB kind of plating to shear, or potentially if you could develop a system like actually CLT or ICLT if the productive or manufacturing capacities could develop in Venezuela, then utilizing those materials. Looking at the service core here three-dimensionally, just this idea of these this kind of service areas that move or function vertically in the building and allow for kind of flexibility of how you plug into them, and looking at interior partitions. So here is just kind of looking at what are some of the actual vernacular constructive techniques. It could be these bajareque construction walls, which are actually made with kind of hardwood posts and cane wattle and daub that are used as partitions, or then just starting to embrace this idea of the more lightwood framing, which is typically a more kind of North American concept, and then even to a more precise way of building partitions with LVL, which is maybe a more kind of stable product, or more precise. And then exterior envelope, again looking at the potential at the kind of lower spectrum of the more economically accessible, building with a kind of cane wattle and soil infill as insulator, and then moving into actual lightwood framing with bad insulation, or these more developed systems of engineered timber and exterior rigid insulation. And then finally, things like the shading devices on the building, which it could embody. So this starts to get at just the expression of a wood building also as an architectural device, not just this concealed kind of element. So basically from there, started with developing a kind of a linear typology, looking at that as at that architectural scale and working out some of the details of how it would work. So just looking at a typical floor plan. So on one loaded scheme that could potentially have this kind of breezeway. Really, the project is focused on this more like mid-rise scale. It seems more feasible, as a starting point. Probably like a 4 or 5 story unit height, and as a parting point. And basically, yeah, looking at just the potential of this, if you're introduced this really flexible system that could okay, thanks, man. That could kind of incorporate, that could allow different units to happen, different arrangements. That there's a certain architectural richness to that, and within that, maybe disarray, how architectural elements can start to regulate some of the expression of the building. And obviously, like a lot of these design decisions are also informed by the response to the climate and the solar exposure. Really generous overhangs on the southern exposure, which is just based on kind of precedent, looking at built work, and these shading devices being really critical to a kind of tropical architecture. And then, looking at how these panels might fold in the maybe eastern and western portions of the building and start acting as vertical fins to block eastern and western light. These are some sections, kind of just looking at, how those systems might work sectionally, both in terms of the functional kind of wet cores and how like the line of the enclosure can play with different depth balconies and such. And the idea of these social spaces in the breezeways is a social catalyst. And then, just very diagrammatically or generically leaving the ground floor is something that could potentially be just commercial space or building amenities. And then, this section here starts to look at what the potential of like this lofted type of unit might be, and how that could happen within a system that incorporates both one-story and lofted units. And then finally, just like I think I wanted to this is an overview of the constructive sequence at a larger site scale. Pretty self-evident, so I won't kind of get into that, but yeah, basically these are just some diagrams here. Looking at those streams, which I've named self-built, hybrid, and traditional. So a more traditional system, which is based on this idea of manufacturing material, having delivered to the site in a conventional way and installed, through trained labor, obviously leading to generally a more, higher quality type of building, perhaps more costly, arguably, and in less time. But then conceptually thinking about how some of that user empowerment can start to, perhaps something that takes longer over time to develop, but as long as this initial framework is there, it can allow users to build on to these kind of units and do so at a reduced cost. So these are some zoom-ins there of those diagrams. And then, this is kind of the intersection of this idea of the user versus designer input, and looking at, I didn't really explore specific sites in the in Ciudad Guayana, but I just, kind of started imagining what in an urban context, if you have more of a rectangular square lot versus a corner versus a linear lot in a more high density urban area, and how that might kind of start to inform some of the scale and architectural expression of those prototypes. So, this is what might be the kind of more self-built architectural expression, which is a bit of more of a mid-rise density or low-rise. And you can start to see here how some of the maybe, cladding materials that might potentially be self-built, start to be also in a way regulated by these more rigorous architectural elements that are in the control of the designer, and how this might adapt to maybe a more middle class kind of neighborhood, and start to take up a larger scale and have to start to have more of a sectional play with terracing perhaps, And even just considering what a high-rise timber building might look like with this typology. So that is the presentation. And yeah, I will open the floor to comments. I hope sometimes I maybe get tangled up in some of the concepts, but hopefully they came across. I think what's been hard about this project is it's just kind of jumping in scales, and things don't align perfectly from one scale to the other. So, but the idea is that it's been this precise incremental system that also kind of gains complexity as you incorporate more factors. So that's sort of where I'm at.
Thank you, Diego. Let's make sure we give some time for feedback.
Diego, I have followed your work for a while, and I want to really commend you for coming up at the climax, the pinnacle of your education here, or your courses here. And I think your project is correct and really good on many aspects. But I want to ask you to elaborate a little bit more on some conceptual issues that are present in your project, but I think you are letting them kind of escape through your narrative. Ciudad Guayana is a resource extraction city. It was a city that was designed and built to do resource extraction. Not the oil of the coast, but the mining and the pine of that region. That's the Orinoco River, right? That's
yeah.
Orinoco
River
of the Orinoco Valley.
Moving north.
If you look at Felipe Correa, the chair at Virginia UVA, has a great book about resource extraction and resource extraction in South America, mostly. So there is a really great opportunity there to engage with the issue of resource extraction and carbon and CO2, and kind of not reframe, but present your project as a way to capture carbon and lock carbon into timber. If you elaborate a little bit more on that, most of the trouble that Venezuela is going through in the last decade is a consequence of oil. There's lots of literature about the oil curse, how oil destroys local industries and creates an imbalance in the exchange rate of currencies, so that it's easy to import everything and really hard to develop any local industries. There's a lot there for you to say, forget oil. It's worth nothing right at this moment, this week. Oil has no value. Forget oil. Let's think about how can we be regenerative and lock carbon, in this case, into timber. Now you have a lot of problems to overcome. That's the beauty of your project. That's the everything that is right on your project. Now there's also everything that can go wrong. Wood construction everywhere in the Americas, mostly in Latin America, is associated with not noble, not for the wealthy. It's the construction of the poor. It's the construction of the Yanomami that you shown, the native inhabitants. It's the construction material of the poor. In the US, less so, but from Texas to the South, you have that to overcome. You also need the industry there, right? I mean, in order to provide the scale that you are proposing, it's not, you can't do that on a workshop. You can't do that on one little shop. You need a whole industry. So between everything that is correct about your project, carbon sequestration, forget oil, do a more intelligent resource extraction, and everything that is an obstacle, how do you balance? How do you sell your project, let's say, for the next Venezuelan government?
Fernando, I think that's a really important point, and I think it points out the questions that I have also, Diego. First of all, the incredible amount of work. I mean, the scales that you're looking at and the sort of social implications of what you're doing is just really commendable. And I'm really glad to see the work has developed this way. It's really impressive. But to the point of extractivism versus regenerative building systems, which Fernando has raised, which obviously has, it's a political economic problem, you know, with obviously huge social and cultural behavioral issues surrounding it. You know, this idea that wood is somehow of a lower quality and therefore associated with poverty is something that actually still exists in the very affluent US. We see that on a regular basis, and overcoming that is something that I think takes some time, and it's a public relations issue to begin to address, and architects are well placed to do that. But to this idea of the systems thinking that I think you touch on, but I think your system is a construction system or a typological system that you're really looking at. If you were to address our truly systemic set of ideas around the architecture that you're generating, you would be looking at the plantation forestry that exists already with Caribbean pine, but you'd probably be studying, I think what your proposal offers is the possibility that there's a sort of mixed species approach to all the different scales of building components that could produce not only the more informal self-built sort of sweat equity housing that you describe on one end of the scale, but even the high-rise housing that could really have a kind of cultural component that does tie back to the sort of pre-colonial architecture. It's interesting that with colonization, you get extractivism, which is what colonization is all about. And then you get the adoption of cultures to these sort of colonial ideals in building, which you point out, which is really interesting. I want to know more about the forests and those synergies that you touch on at the very beginning, because I think it does suggest, as we talked about with Jacob's project before, this idea of generating a new economic reality for Venezuela, one which tries to back itself out of the deep hole that we've all drilled for ourselves with the fossil hydrocarbon industry and the material industries that derive from that. Steel and concrete construction. And so I wonder if you were to just suggest more that the architecture, the range of architecture has really specific material resource requirements, processing requirements. And rather than, to me, it's less of an architectural project, more of a typological project, one that really tries to draw those connections, not just through sort of infographics, but really sort of systemic relationships between those more immediate resources that are renewable, regenerative, and the building practices that follow from them. And I just steer you to a couple of things that you may have checked out, but first of all, you should really look at Saskia Sassen's work at Columbia. She's a sociologist doing incredible work on the informal building economy and the extractivism in the current kind of real estate world, which is it's the force, the counter force that your project has to address, right? Which is how we deploy capital to create housing and consume resources. And I also, not sure you're familiar with John Houbraken, a Dutch thinker around these sort of open building systems, which we see examples of. I think you may have seen with us Pia Ilonen's concrete open building project in Helsinki. But the idea that there are different degrees to which you introduce building components and you allow flexibility, right? Which I think is really, really powerful. So just as you could have a sort of sweat equity self-built system in very low-rise houses, which could be improved from the sort of informal rancho housing that you see, you know, all around the hillsides around Caracas and other cities around South America and Africa, for that matter. But also this idea that you could produce a really convivial system, which is built totally into your project for high-rise building, and really define how the mechanisms of those adaptations by the inhabitants would happen. Like it's almost a kind of temporal based study. And I'm not seeing that in your visualization. I would like to read more fully kind of what you offer and what is introduced as sort of secondary, tertiary processes that evolve with the life cycle of the households who inhabit it. And I think that would be a way to go back into your work and really tune the sort of formal economic system of housing production and the potential of the more informal open building systems that you're trying to touch on. So I agree with Fernando. I'm looking for that big systemic kind of approach to the building, because I think you've gone so deeply into the research of the social implications, but I'd like to know about the resource allocation and systems, political economic systems about that. And then more specifically architecturally, not just the form of the building, but actually how the building adapts over time, because I think you've raised that and it's a really powerful idea. So I think the work's fabulous. I think it opens up a career's worth of potential for you. And I'm so admiring of the breadth of the research. And I look forward to seeing how all of those topics that you've touched on can sort of infiltrate your work in the future. And I really want to thank you for the project.
Thanks, Alan. It's great to hear. Thanks so much.
Yeah, I would really agree. I think this project opens up a lot of really interesting questions and addresses a very important and necessary kind of new way to look at building that could not only be implemented in Latin America, but in lots of other parts of the world as well. And I think maybe the most interesting thing for me that sort of grew out of thinking about this and hearing you talk about it was a kind of perspective on the relationship of wood building technology and government institutions. And what I mean by that was my first thought was when I saw you, I saw the plan of Ciudad Guyana and was looking at these densely packed wood buildings going in here in an area with minimal understanding of the technology and experience with the technology. How do you prevent learning the lessons we in the US and Europe learned the hard way after London burned and Chicago burned and San Francisco burned? Now we know how to prevent that, but in an area with weak government institutions, with limited code enforcement and building codes, how do you, and especially where there's going to be a lot of informal use of these technologies, how do you make sure that these things aren't death traps for the inhabitants? And we're all aware that in Latin America and lots of the rest of the world, particular poorer countries, masonry and concrete tend to be the prevalent construction technologies. And of all the kind of reasons that I've heard for that, I've never heard anybody say, although it may be well studied, that masonry and concrete are much more forgiving. They have a lot of problems, but they're also much more forgiving as long as you reinforce it and the buildings don't collapse, which is of course happened. But with moisture problems, with fire, and even with climate to some extent, masonry can just take a lot more abuse than wood can. And I think one important thing that would be a whole other project in and of itself would be to look at the logistics of technology transfer and how one could actually implement this in a country like Venezuela. And I think it would have to go hand in hand with a lot of government reform as well. So where we assume that if we build a 4-story apartment building out of stick framing, or even if we did it in heavy timber and infilled it with stick framing, that we know there's going to be a fire suppression system required. We know that we're going to have rated walls that probably have gypsum or some other fireproofing on them, and so on and so forth. But when you don't have those kinds of either the understanding or the regulatory structure to ensure that those things happen, then you could have some really significant problems. And kind of the same idea with moisture. If you have people who are informally, building out all or part of their buildings using wood, but without access to access or knowledge of flashing and modern building materials and so forth, how do you make sure that those buildings don't just deteriorate in short order in a fairly hot, humid climate? So I think it's really impressive work and brings up some really extremely necessary questions, and that there's a whole other dimension of studying how this gets implemented hand in hand with the type of structure that we have here in the U.S. that allows us to, by and large, use these things in a safe and durable way, kind of by default. We don't even really understand that we operate within that system because we're so used to it. But in a place where all of that is absent, it would become really apparent really fast, I think.
That's really interesting, Jason. Thank you.
Sure.
Yeah, Diego, really, well, first of all, thank you for inviting us. It's great to see all the work. It's really amazing. It's hard to think that how much you've grown as a designer in just the past couple of years. It's really phenomenal to see this, the volume of work and the range of issues that you're tackling, both in your research and your design. I think, and what it kind of, to tack onto what Jason has raised, I really appreciate that we can get to this level, like talk about moisture management in a graduate thesis. Like, I think it really speaks to that you've brought a lot of issues to bear, and that we can actually examine from a range of scales, from socioeconomic issues to waterproofing details. I think it's a testament to the issues that you're bringing to the table. And I think one kind of thing that you brought up in your presentation, you kind of described it as creating this framework that creates flexibility, which therefore creates resiliency, which I really appreciate you structuring the argument in that way, because I think it really adds a compelling aspect of your project that could be leveraged into kind of future systems morphologies, and you can really see this becoming a genesis for a new way of construction in these types of contexts that you're describing. And I guess what it brings up for me, at least personally, is like, what are the mechanisms to ensure flexibility? And I think that what you've described, what Alan brought up as the open build concept, I think is fairly well acknowledged, that you can build a structural frame, and that through regulatory permissions or structuring of the tenant leases, you can allow for people to infill that housing. And that's fine. It raises kind of procedural issues, but doesn't necessarily weigh on the technology. And I think what you're getting at is that you're describing a new industry, a new technology. And so you have the opportunity to not only craft a narrative about the building morphology, lending itself towards a certain way of inhabitation, but you have an opportunity to inflect the way that the industry itself develops. And so if you think of, let's say CLT manufacturing in the US, for example, it's driven around a need to maximize the panel for shipping. And so you have 8 to 10 foot panels that are 55 feet long, and that's because that's a truck, and that's it. But I think in your case, you might say, well, what's the panel dimension? What are the structural members that can be moved by 2 people to ensure future flexibility, that they can actually remove floor panels and they don't have to bring in a mobile crane, or they don't have to dismantle your neighbor's apartment above you to get to it? And what does that mean for the size of the industry? Maybe that requires a smaller capital investment for the manufacturing side. Maybe that requires smaller capital investment for the transportation side. So you are able to kind of craft a narrative about this burgeoning industry that you're describing and proposing that is more kind of democratically accessible, that doesn't require such a top-down single point investment. I think it through that mechanism of flexibility, I think you can touch on a range of topics that you've already begun to outline. And I think that could be really, if you were to take this into like a policy proposal to this Venezuelan government, I think could be really compelling and could speak to a host of issues that are probably really pressing at the moment.
Thank you, Andy. That really speaks to the kind of core of like the outset of the project. And I think that doesn't necessarily read as strongly because I got into other things, but I think I did keep kind kind of circling back to that idea of, it's like this piece of wood, like you can kind of move it around really easily. What's the potential of that to kind of build up and create these systems that are not reliant on these more kind of typical or traditional ways of building.
Yeah, and I would just add, because I think that what Dason said and what Andy have followed on are really important things about how you delineate what's really feasible, say, in a mid to high rise structure to solve all of the issues that Dason's raised, but allow a certain amount of flexibility. What is it actually, what is the bandwidth for flexibility, for expansion, et cetera? How do you protect the space that isn't occupied for as long as it's not occupied? All those questions. But I think I would say that can be addressed or seen by you through your visualization techniques. I just want to tie it back to that, because that's our tool, really, right? And I think that's what these guys are raising is really, really critical. And the only other thing I want to say is that part of the sort of informal building economy, which Saskia Sassen writes about beautifully, is that it relies on a kind of circular economic approach, right? These people are not tapping into the political economies of Home Depot, big box stores, global transport, et cetera. What they're doing is kind of like finding and using scarcity as a model for production. So what is the future version of that isn't informal, unhealthy, dangerous? And how do you model circular economic construction strategies on top of a reformed building economy and political economy around mineral and resource extraction? So I can't help but think that you're like already touching on these transcalar issues, and they do zoom right down into construction details. But your construction details look a lot like, the construction details of an advanced American building economy, and a lot less like some of the analyses that you did early on in your project. So I just want to throw that back out there, because I think by Dason and Andy touching on these topics of constructability and life safety and barrier-free building and all these kinds of things, like you get right to those basic questions about where the resource comes from and how you manage it.
Thank you. This is really great feedback.
Yeah, I think these are all great comments. I'm going to stop the screen share for a minute. Diego, thank you so much for the work this semester, and the comments. I think the comments were all spot on, and they kind of highlight the breadth and the complexity of what you're obviously looking at. But I really appreciate your enthusiasm, and we've talked a lot. I think Ellen is talking about the temporal character and how can we convey that visually. I think we've talked about a lot of these things, right? And so it's just just like Jake, in the end you're just a one-man show, right? Trying to do it all. So it's an incredible accomplishment. Kind of, I can, just kind of based on the enthusiasm you've exhibited over the last 2 years here, I don't have any doubts that you'll carry that onward in your professional career. And I want to really thank our reviewers today. I want to thank Andrew and Ellen for joining us and taking time out of the busy schedule, as well as Dason and Fernando. Really appreciate it. Thank you, everyone.
Thank you, Uli, and congratulations, Diego.
Thank you so much.
It breaks my heart a little bit that we're not able to have an in-person commencement ceremony. I think I feel for all the students, but hopefully we'll be able to toast sometime soon when we can meet in person again.
Yeah, invite us back. We'd love to do that. And also, Uli, Fernando, Juliana, really impressive work. Andy and I sit on a lot of reviews, and I will tell you that these are standouts. And I really congratulate you as teachers and advisors too. And Dason, great to meet you, man. Thank you.
Great meeting you as well. And yeah, thanks everybody. Great work, Diego and Jacob, if you're still there.
Yeah,
thank you.
Work, Diego.
Jacob's right here. Yeah, got the virtual background on.
Thank you.
Thank you so much for your time. This is really amazing feedback and discussion. And yeah, I mean, it's sort of anticlimactic ending. It's like, oh, we're done with our Zoom presentation. Now what do we do? But, thanks for being here with us. And right.
Great work, both of you. Thank you for your presentations.
Thank you.